Welcome to EDU World Space.
We're asked to analyze this beam that is attached, has a cable attached to one end of it that's attached to a wall. It's inclined here and then it rests on the ground. Forces acting on the beam are a normal force from the ground and a friction force from the ground. The weight of the beam and the tension in this cable. Now we can take moments about this point here so that these two forces drop out, and we get the moment from this is T times L sine of theta, which so the moment arm is this angle, is this distance here, so L sine of theta. And then here we have mg L over 2 cosine of theta, because the moment arm here, this is L over 2, and the moment arm here is L over 2 cosine theta. And that has to sum to 0 for this to be in rotational equilibrium, and we can again get what this tension is in terms of the weight, and it is mg over 2 times the cotangent of theta. Now, if we're told that it is just about to slip at this in this configuration, then we know that this force has to be mu, the static coefficient of friction, times the normal force, so we have that relationship. We also know that if we sum forces in the horizontal direction, that minus t plus f has to be 0, or that t has to be equal to f. And that we know has to be equal to the coefficient of friction times the normal force, and we know from a vertical force balance that the normal force has to be mg, and so that we see that the static coefficient of friction would be cotangent of theta all over 2. So if we were to try to measure this, we would keep moving this thing in and in and in until it just was about to slip, and then we would be able to figure out from the angle what that coefficient of friction was. Now if we move it farther in, that means that theta is going to decrease, which means cotangent of theta is going to increase, so we need a greater coefficient of friction. So if we had the same coefficient of friction and we move this farther in slightly, then it's going to slip, because we're right at the critical point between where it isn't slipping. If the end was touching anywhere over here, it wouldn't slip, but anywhere over here it's going to slip.